the same.
I know, and that's like one of the things that might.
Every one they give you is an identity. So you spend all your time verifying identities, and yet when you get a multiple choice, you actually have to figure out if one thing is not the other.
Yeah, I know, definitely. And that's why I'm kind of worried about the verifying identities, and might even want to go over that a little bit more here.
It would be a cruel teacher if he put a lot of those on there.
Yeah.
They're so hard. Verifying is hard enough, but multiple choice makes it about a factor of 5 harder.
So, yeah, 'cause you have so many that you could find.
Well, yeah, you kind of have to do all 5 of them, right? I mean, if they give you 5 multiple choices, you start with the first one and see if you can verify it. If you can't,
well,
go to the second one. But just because you can't verify it doesn't mean it's not an identity. Some of those identities are hard.
Yeah.
So,
I would think that the way you could go about it was maybe like going to try and simplify the identity and then just see if you go along the path and find the other one.
Kind of have to use your gut. But you're not taught that if I get sine x equals cosine x, does that verify that they're not an identity? Does it? Let's say that I was doing multiple choice and I was analyzing answer A and I turned it into sine x equal cosine x. What does that mean?
If you what? I'm sorry, I didn't catch that too much. If you take what and turn it into what?
If I had a verifying identity problem and I had multiple choice answers,
yeah,
and I took the first one and tried to prove that it was an identity, and I got down to this step.
Okay.
What would that tell me?
Not much.
Yeah, yes, it does. It tells you it's not an identity. There's no way sine x is equal to cosine x. There's only one x that would be true, and that's pi over 4.
Okay.
But for all other x's, it's not true. And an identity has to be true for all x's. If I say sine squared of x plus cosine squared of x equals 1, which is an identity, that's true for any x you plug in there, any angle you want. That's true. Whereas this one up here is not. That's only true for one angle. So
okay.
It's not super easy proving identities are not right. Just because you don't have much practice in it. That's the biggest reason. They don't give you any practice in it. That's why it's cruel to have you do identities the normal way all year and then give you a test that's multiple choice because it's asking you to do something that you haven't done.
I see. Huh.
But sometimes you can kind of work your way through it. You can pick one of the multiple choices that you think is right and spend some time trying to prove that it's an identity. And if you can't do it, then go forth to the next one. Still going to be a tough problem because there's a lot of identities that after 5 minutes I can't prove it, and yet it's still an identity. I just haven't found the right way to do it.
See how that works. Okay.
Yeah.
Cool. All right. Well, tonight was the same thing, dealing with double identities and half angle identities.
Okay. Let's talk about those. You got a specific problem?
Yeah. The first one is 2 sine of theta equals sine squared of theta plus 1.
That it?
Yeah.
What are we looking at?
A quadratic.
Correct. The way you solve quadratics is to put everything on one side and 0 on the other. Now factor that. What do you get?
You get sine on each side and 1 on each side, and it would be both negative. Sine squared minus 1.
So what's the answer?
Sine of theta, theta equals 1.
Okay, sine of theta equals 1, but they want
So that means
to solve for
theta equals, theta equals pi over 2.
Yeah, now if they limited your domain to the unit circle, that would be your only answer.
Mm-hmm.
If they didn't, then your answer is pi over 2 plus, use n or k?
We use n.
That would be the answer.
Okay, yeah, I remember that. Okay.
That applies to the entire domain, all real numbers. And n is just an integer, positive or negative, from negative infinity to positive infinity. In other words, all multiples of pi over 2 plus 2 pi satisfy this equation. Make sine of theta equals 1.
Okay.
Okay? Most important thing is recognize you have a quadratic. And the moment you see a quadratic, it's just like a algebra problem. In other words,
Okay.
there's no difference between that problem right there and this problem. 2x equals x squared plus 1. Exactly the way I would solve that, I'm going to solve the trig problem.
Uh-huh. Okay. Cool. The next one is sine squared of theta, or sine 2 theta.
Sine cube?
No, 2. Sorry, sine 2 theta.
2. Oh, 2 theta, okay.
Yeah. Sine 2 theta minus 2 cosine squared of theta equals 0.
Okay. It's not always impossible, but usually when you have a trig equation, you want to get everything in the same trig function.
Mm-hmm.
So what's an identity for that?
An identity.
In other words, I can't do much with this. I got 2 different trig functions, and I got one argument is theta, the other argument's 2 theta. So it's hard to make any progress on this unless I use a trig identity. Well, what's the double angle identity?
That can become 2 sine of theta cosine theta.
Now, notice I can factor. In other words, I still don't have everything in the same trig function, but I don't necessarily need it. If I can get this to be the product of 2 things, I can solve it. Well, what's our greatest common factor?
Cosine theta.
2 cosine.
2 cosine theta. Yeah.
Leaving
2 sine theta minus
I factored the 2 out.
Oh, so sine theta minus 2. Or cosine, because it's squared, I see.
Whenever you're factoring, especially greatest common factor, always be checking. By that, I mean by the time I've ended up finishing that line, I've checked it in my head. I've multiplied that times that to make sure I got that, and I've multiplied that times that to make sure I've got that.
Okay.
The reason you want to do that is because when you make mistakes, you want to catch them right then and there. You don't want to solve this entire problem and then look in the book or the answer and you get it wrong. You want to catch your mistakes as you go. And the way to do that is to always be checking.
Okay.
Now what?
2 cosine theta is equal to 0.
Means
So divide by 2, cosine theta is equal to 0. Theta is equal to 0.
No.
Cosine.
Hold on.
Okay.
Cosine of 0 is not 0.
Okay.
Cosine of pi over 2 is 0.
So, yeah, so it'd be pi over 2. Sorry, that's what I was getting at.
Okay. And then what else?
I'm unsure where to go with the sine of theta minus cosine of theta.
Well, let's set it equal to 0. We know that much,
Okay.
right?
Yeah.
In other words, it's the rule of algebra. If you have the product of two things equals 0, then you set both of them equal to 0 and solve. Now, this means sine of theta has to equal cosine of theta, which is kind of odd. That's what I just put up there.
Yeah. Huh.
That is not an identity, incidentally. There is
Yeah.
only one theta where that is true. What is it?
Sine of theta equals cosine of theta, pi over 4?
Yeah, at least that's the only place in the first quadrant. No place in the second, no place in the third, no place in the fourth. I guess the answer would be pi over 4 plus n times 2 pi. If the domain is not restricted. That's your answer. Well, excuse me, there's two answers. Theta equals pi over 2 plus n times 2 pi, or theta equals pi over 4 plus n times 2 pi. And I don't think I can express those two series in one statement. I think I have to have two different answers like that.
Yeah. Okay. Yeah. I think that's correct.
Yeah, you could draw out some terms and see, and sometimes you can get away with a single series, an infinite series, as an answer, but it all depends on the problem. In other words, if I wanted to figure out what my answers were, well, pi over 4 is 1, pi over 2 is 1, and then the next one is 9 pi over 4, and then 5 pi over 2, which is 10 pi over 4. There's no series. It goes 1, 2, 9, 10, and so there's no series that I can describe that handles 1, 2, 9, 10, and then the numbers after that. So you have to use two different series.
Okay.
Now, are they giving you these problems with an unrestricted domain, or are they telling you that theta is always between 0 and 2 pi?
They say always infer theta is between 0 and 2 pi.
Let me give you a problem then.
Okay.
This is not obvious. And the only time this is hard is when they do restrict the domain.
Okay.
So what do I do here?
You could...
What's 4 theta have to be equal to?
You could maybe factor out.
Nope.
Or 4 theta has to be equal.
This is tricky. Yeah, let's just go through the solution. I'll tell you the answer, and I'm just making you aware of it because it's a little tricky.
Okay.
So what's 4 theta equal to? Remember that's an angle. That's all it is. Whether I call it 4 theta or theta, still an angle. The sine of what angle is equal to 1/2?
Yeah.
What angle?
Sine of 4 theta is equal to 1/2. Wouldn't it still be 1/2 at 30? Okay, yeah, 30 degrees.
Where else? In the unit circle.
Sine is 1/2 at 5 pi over 6, so that's 180 minus 150 degrees? Yeah.
Okay.
50 degrees.
And now I'm going to divide everything by 4. So I get theta equals 7.5 degrees, or whatever the heck that is, 37.5 degrees, I think. That looks like my solution, but it's not.
Okay.
Okay, here's what I didn't do. If the domain on theta is between 0 and 2 pi, what's the domain on 4 theta?
Huh. I didn't think I thought that through. 4 theta,
Multiply both sides by 4. Gives you a domain of 8 pi.
oh.
Which means I have to go all the way up to 8 times 180. Which is 14. What is 8 times 180? 8 times 180. 1440. So I got to go all the way up to 1440 degrees when I solve for 4 theta.
Oh, wow. Okay.
Now watch what happens though. Okay, so all I do is add 360 to the 30. So that's another solution. Add 360 to the 150. And I keep going all the way up to 1440. I don't want to take the time to do all the arithmetic, but I think you get what I'm getting at here.
Yeah.
Now, when I divide each of these answers by 4, everything I get, I'm going to get 16 answers. But the last one is going to be inside the unit circle. It will be an angle less than 360. Because I'm taking this last angle and dividing it by 4. So my final theta is indeed in the unit circle, but there's not 2 answers, there are 8 answers.
Oh, wow. Okay.
And that's not obvious on this. This you have to do 1 or 2 of these to know how to do them. And there's probably various ways they teach them. I've seen different techniques taught on how to handle this. To me, this is the easiest one. The easiest one being when they restrict the domain of theta, figure out what the domain of 4 theta is. And then when you're solving for what 4 theta is, you go all the way up to the 8 pi in terms of your angles.
Huh.
Then when you divide all 8 of these answers by 4, you're going to get 8 answers that will all be in the unit circle. So it's kind of nifty, but it's tricky, and 90% of the students are going to leave out those 6 answers right there. They're going to get these 2 right here only, because they won't go beyond the unit circle. In other words, they'll stop right there when they get 30 and 150, because they're thinking the domain is the unit circle. Well, that is the domain for theta, but it's not the domain for 4 theta. The domain for 4 theta is 0 to 8 pi, in which case you have to list all the angles out to 8 pi, and then divide every one of them by 4. All right.
Okay.
I don't know if you're going to get problems like that, but you might.
Well, it's good to see it, though.
Yeah, and they may give it to you in a simpler format like that. Don't get trapped into switching that to 2 sine theta cosine theta. That will not help.
Okay.
It'll only make it tougher. In other words, you want to do this one the same way I did 4 theta. This means my domain goes from 0 to 4 pi, and I find all of the answers that satisfy 2 theta, and then I divide each one of those by 2 to solve for theta.
Okay. Cool.
All right. What else do you have, Nick? So what math are you taking next year, Nick? Are you a stats man also next year?
Yeah. Uh-huh.
All my pre-calc students are taking stats next year.
Oh, no.
I may have to spend the summer refreshing my stats knowledge. I don't know. I've never seen this before. I've never had, I know at least 3 of them that are juniors
Oh, wow.
that are going to be seniors next year, and they're all taking stats instead of calc.
It's become a pretty nice option over calc if you kind of know where you want to go to college or have decided that already.
No, we talked about this before, and you gave me your
yeah. I know about colleges really like to see calculus on the high school exam.
Yeah, well, and in your situation, that's not going to apply. I understand.
Yeah.
You can wait and take calculus as in college, and I'll be available to help you then. So it's not like we're probably not ever going to work again together, but
No.
it's just a bit odd that all of my pre-calc students, most of them are really good students, like yourself, and they're all taking stats next year.
Huh. Do some of them attend Chatfield, I would assume?
I've got Chatfield. I got students all over the city, actually.
Oh, wow.
Ralston Valley, Highlands Ranch.
Oh, okay.
Yourself, Columbine. You're at Columbine, right?
Yeah, I was at Chatfield originally, Columbine, but now.
Yeah.
Mm-hmm. Yep. Okay. Well, the next problem on here is a half-angle identity.
Is a what?
A half-angle identity.
Half-angle identity, okay.
So it's -3 sine of theta over 2 plus 2 equals cosine theta.
Okay. What's that identity? In other words, the thing I can see here immediately is that, first of all, these half-angle identities are all functions of cosine.
Yeah.
So I can convert that to cosine immediately.
Yeah. Okay.
Good. And then we'll have everything in cosine, and who knows, it's the square root of something, so I'll square everything, and then I'll have a quadratic. That's how we're going to go on this problem.
Okay.
So what's the half-angle identity?
It is plus or minus root 1 minus cosine theta over 2.
And this 2 was outside of that, right?
Yeah. Mm-hmm.
Now what can I do?
You could move the 2 over to cosine theta, so it'd be -2.
It's not going to help that much, but it might help a little, I guess. All right, let's do that. Let's move the 2 over and divide both sides by -3.
Yeah.
So I'm going to end up with this. Equals cosine of theta minus 2 all divided by -3. Now, what's the next step?
Maybe squaring it so you could get away with the.
You got to get rid of the radical. You got to get rid of the radical sign. Yeah, we're not going to be able to solve this with a radical sign. And the way you get rid of radical signs is isolate them like we have now, and then square both sides. Well, when I square the left side, what do I get?
When you square the left side, you get 1 minus cosine theta over 2, right?
Huh? In other words, the plus or minus sign goes away.
Yeah.
And when I square the right side, that's a little harder.
You get
square the top and then square the bottom. What do you get when you square the top?
cosine squared of theta minus 4 cosine of theta plus 4.
Glad to see somebody who does that properly.
And then the bottom is 9. Yeah, 9.
Okay. In other words, you did it based on your formula of what a minus b squared is. Which is the way I like to see everybody do it.
Thank you.
Now we've got a cosine squared. We got some number of cosines. We got denominators. I can almost certainly turn this into a quadratic with 0 on one side. Let's do it.
Okay.
First best step.
Maybe multiply both sides by 9 to get rid of the 9 first.
How about multiply both sides by 18?
Oh, the least common denominator. Okay.
Yeah, that'll get rid of both denominators in one step. Your way, I would multiply both sides by 9, and then I'd multiply both sides by 2, right?
Yeah, so you get to 18 either way.
Multiplying both sides by 18.
Plus 8.
Okay.
Yep.
Now let's put everything on one side, and I'll make it the right side because I've already, I've already got a positive coefficient there, and that's the only squared term I have. How many cosine thetas do I have on the right side?
Just one. Just one positive cosine theta. And then it would be minus 1.
Okay, and that's going to factor pretty nicely. And it's always going to leave 0 because I subtracted both of those terms. So this factors into what?
It factors into 2 cosine theta and cosine theta, and it's a 1 on each side, and the positive will be on the right side with the cosine theta. Good. And the negative will be on the left side.
Okay. So what are my answers?
Cosine theta equals 1/2, and cosine of theta equals -1.
Where's the 1/2 occur?
The 1/2 occurs in pi over 3. And 5 pi over 3.
Okay, that's in the unit circle. I'm just going to assume that if you can get the unit circle, you know how to do the infinite series one.
Yeah, plus 2 pi.
Yeah, just add 2 pi to each one. You're going to need 2 terms. In other words, it would be pi over 3 plus k times 2 pi. And
if I got answers that were diagonal from each other, like pi over 3 and, well, I guess 5. No.
No.
If I got like pi over 3 and 4 pi over 3, would I still have to add 2 pi to both of them?
7 pi over 3. And the next term after that is going to be 11 pi over 3. And the next term after that would be 13 pi over 3. Now, I don't see any way to put all of those in a single sequence.
No. But if I got one that was...
a sequence of 1, 5, 7, 11, 13, I can't define that with one sequence.
But if I got answers that were like pi over 3 and 4 pi over 3, could I define that with one sequence?
If it went all the way out, you have to...
Okay. Oh, I see. I see how... Okay.
You got to go at least 2 unit circles and maybe even a 5th term. Then Then sometimes you get one that looks like pi over 3 plus 2 pi over 3 plus 3 pi over 3 plus 4 pi over 3. Then you could do it with a single sequence. This is actually going to end up taking us 3 terms because I've got this other answer down here. Where is theta? Where's the cosine of theta equal -1?
Pi.
So it's really pi over 3 plus n times 2 pi. That's one answer. or 5 pi over 3 plus n times 2 pi, that's another answer, or pi plus n 2 pi. In other words, 5, 3 pi, 3 pi, 5 pi, and so forth.
Okay.
So those would be your three answers for this problem if they did not restrict the domain.
Yeah.
I don't be giving you these infinite series if all of your problems restricts the domain from 0 to 2 pi. Then I'm just
No, yeah, I see.
wasting your time and maybe confusing you, because these are definitely harder answers. Although the one case where they're not harder answers is that one where, like the sine of 2 theta. In other words, you wouldn't make a, if I said the sine of 2 theta equals 1/2 and I didn't restrict the domain at all, then you'd give an answer in an infinite series format.
Yeah.
And you wouldn't miss it. But if I said theta is restricted from 0 to 2 pi, that's where you can make a mistake on this problem. Because that means 2 theta would go from 0 to 4 pi, and you'd have to come up with all the answers that go from 0 to 4 pi, and then divide each of those by 2. But you get twice as many answers is the bottom line, is when you have problems like this, where they have restricted the domain. Now, if they don't restrict the domain, you can define that as an infinite series, and it's real easy. You know, it's pi over 6 plus n 2 pi.
Yeah.
In other words, the domain issues kind of disappear because I'm giving an answer that has an infinite number of terms in it.
Okay. I see how that works, yeah. I see what's going on there.
So some are harder, some are easier, depending on whether they restrict the domain or not.
Okay. Well, other than that, I just want to keep working on identities to try and get a little more solid with these.
Okay.
This is the one thing that I'm kind of shaky on in my final. The next one is sine squared of theta times cotangent of theta all over cosine of theta, and then it just wants you to simplify it.
Okay. That's probably easier than a verifying.
Yeah.
Because
my first thought
when you're verifying, you have to turn the left end to the right.
Yeah.
When I'm simplifying, I'm just going to get it down to as few terms as possible.
Yeah. Okay.
So
well,
the first step.
Maybe turn the cotangent into cosine over sine.
Reduce that.
And then if those are multiplying, couldn't I take out a sine squared?
You can do that.
And then the cosine is multiplying the sine, I can just take out the cosine squared, right?
Not the cosine squared, the cosine.
Or the cosine theta, sorry.
And you're left with sine theta.
Sine theta.
So if it was going to be a verifying problem, your right side would be sine theta. I'm guessing. I mean, if I was going to make up a verifying question, this would be a pretty good one.
Yeah. Okay. The next one is cosecant of theta times secant of theta minus cotangent of theta is equal to tangent of theta.
Don't have any sines and cosines in this whole thing.
Yeah.
But I can turn every single thing into sines and cosines relatively easy. I can turn that into sine or cosine, that into sine or cosine, that into sine and cosine, that into sine and cosine. That almost certainly is what you want to do.
Okay.
So let's do it, term by term. What's this?
Cosecant becomes 1 over sine of theta. Secant equals 1 over cosine of theta. Cotangent becomes cosine over sine of theta. And tangent becomes sine theta over cosine theta.
I don't need to write that yet. Some teachers are particular about not touching the right side.
Okay.
And that's fine, as long as I know that that's sine over cosine. In other words, if I can get the left side to read sine over cosine, I'll be in business. Right? I don't need to mess with the right side. I just need to make the left side read tangent of theta, or one step earlier, read sine of theta over cosine of theta. Now, how do I carry out this operation? Whoops.
I would think of first combining the left side of that, so it'd be 1 over sine of theta cosine theta.
Okay.
And then maybe cross multiplying.
Not cross multiplying. Although that's an interesting thought, but that's one of the things they don't allow you to do when you're verifying trig functions. You can't do things like cross multiply. I can't multiply both sides of the equation by sine of theta. I can't do all those typical algebraic techniques.
Okay.
It's a restriction they put on it because remember what the purpose of this is. The purpose of this is to learn your trig identities.
Yeah.
There's no other purpose. And if they allowed you to multiply both sides by something, then you're not going to learn your trig identities as well as you will if you do it within their rules that they have placed on it.
Yeah.
How do I subtract one fraction from another?
Finding the least common denominator.
That's always where you want to go.
Okay.
When you see fractions being added or subtracted, what's the least common denominator going to be?
Sine squared, or sine theta cosine theta.
Top left still going to be 1. Top right is what?
Sine of theta times cosine theta.
Okay, I'm going to write it like you told me.
Okay.
Now always be checking. Is that the same thing as what's above it? In other words, what you should be checking is that the same as that? Because they have to be the same. Otherwise you've made a mistake.
No, it becomes cosine squared of theta.
Okay.
Sorry.
That's all right. I just want to get you in practice of checking. In other words, now I can check it really easily. In other words, I can see that that 2 cancels with the cosine of theta, and I got cosine over sine, same thing I started with.
Yeah.
Now, combine these two things, and you get 1 minus cosine squared over sine cosine, right?
Yes.
What's 1 minus cosine squared equal to?
Sine squared theta.
Now simplify.
You could take away the sine squared theta, or the sine squared and the sine from the bottom, and become sine theta over cosine theta, and that is tangent theta.
Right, and then I can write one more step that that's tangent theta. And now I've proved that it's an identity and I've never messed with the right side. Now, not everybody objects to you messing with the right side. And certainly in your mind, If it makes it easier, do it. In other words, it was helpful knowing that what we were trying to produce on the left side wasn't tangent theta as much as sine theta over cosine theta. That's what we were trying to produce. And that's what we did produce. And if I don't know if any teacher would take objection with you turning that in first like that.
Yeah.
But some might. Some might. There's no hard and fast rules about being unable to touch both sides. But the one thing you cannot do is things like cross multiply, or if I had something like the following. If I had sine theta equals sine theta tangent theta, you cannot divide both sides by sine theta.
Yeah.
That's one of the rules of verifying. You can't do stuff like an algebraic equation. In fact, even if it was an algebraic equation, I wouldn't be able to do that. I cannot divide both sides there by x. The reason is that x might be 0. And if
I see how that
is
works.
a possible solution, I'm going to completely lose it. Notice that if I divide both sides by x, I get, the only answer I get is y equal 1. When clearly x equals 0 is an answer, right? 0 equals 0 times y. So x equals 0 is an answer, but I lost it because I divided both sides by x. Again, violating the most important rule in math. Don't divide by 0. Or don't divide by variables that might be 0. Well, sine theta can be 0. That's 0 at 0 and 2 pi, or all kinds of places where that's 0. So if that is a possible solution, I would lose it. But when you're verifying trig identities, you can't do that anyway, whether or not this could be 0 or not. In other words, some trig functions cannot be 0. That can't be 0. So theoretically, if I had something like this times x, I could divide both sides by cosecant of theta, and I get x equals 1.
Okay.
Okay? And that would be okay because that can never be 0.
I see how that works.
The range on cosecant is it's greater than 1 or less than minus 1. But it's never in that range that sine and cosine are in. Sine and cosine are always between minus 1 and 1. The cosecant and secant are never between minus 1 and 1.
Okay. Okay. Well, I just have one more problem.
Okay.
The last one is cosine of x, cosine of theta, sorry. Cosine of theta. Sine of theta equals 3 cosine of theta.
Really? That's an identity?
Yeah, that was the last one that we had.
Cosine of theta, sine of theta equals 3 cosine of theta. Okay. That's interesting.
Yeah.
Notice what I would have if I did divide both sides by cosine of theta. What would I have? I would have sine of theta equals 3, which is impossible.
Yeah.
Whether cosine of theta is 0 or not does not produce.
Okay.
That's not an identity.
Well, I see why you put this one on here. It's a trick question.
First student I've had in 8 years where they gave you an identity that was not an identity.
So this is the one problem that it was like the challenge, the bonus.
Yeah. No, actually I like it. I really like it. Now, in terms of solving this other ways, I can certainly turn that into cosine, right?
Yeah, yeah. Well,
What would I get?
yeah.
I would get the square root of 1 minus cosine squared of theta. That's sine of theta, right?
Yeah.
Now, I guess I'd have to square both sides. Excuse me, theta. And now I'm going to see my error of my ways. Well, maybe not. Hold on a second.
This is the challenge problem, and we kept asking. We were like, could this be a trick question? And he's like, I won't tell you until the final. It doesn't count for any points, but it might count for bonus points.
I like it. I love this problem. There's what we have, right? And notice I moved the 9 cosine theta to the other side rather than divide both sides by cosine squared theta.
Yeah.
Because cosine theta can be equal to 0, so I can't divide both sides by it. Whether it's a trig verifying or not, you can't do that. Now I can factor a cosine. Well, I can. That's
factor a cosine squared theta.
I don't need to factor it out. I can combine the cosine squareds like that.
Okay.
Now I can divide both sides by -1 to get to there. And now I can factor out a cosine squared theta times cosine squared theta plus 9 equals 0. So that could be 0, which means theta could be pi over 2 or 3 pi over 2. But this is impossible. Cosine squared theta plus 9 cannot ever be 0.
Yeah.
That would require cosine of theta to be equal to 3. -3, in fact, but that has no solution. So we have one solution only. Let's see if that actually works. Yeah, it's not a no solution problem. I came up with pi over 2, right?
Yeah.
So cosine of pi over 2 is 0. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. It is true. As long as theta is equal to 0, that's the only thing that makes that statement true. Is when theta equals, not 0, excuse me, pi over 2, when cosine of theta equals 0.
Yeah.
And in fact, did I do that right? Yeah, because it was cosine squared. So, same thing. If cosine squared of theta equals 0, that only occurs at pi over 2 and 3 pi over 2.
Cool.
In the unit circle. Here's one. Notice, if I keep going, now here's a series where I can represent.
You could, with just one.
With just one. That's pi over 2 plus n pi. Every term is separated by pi.
Yeah. Okay.
And so that would be my only answer. This one was not a verify, right? This one was a solve the equation?
Yeah.
Okay. Because, in other words, it's not an identity. Cosine of theta times sine theta is not always equal to 3 cosine of theta. But there is one particular theta where that's a true equation, and that's pi over 2 plus n pi. All of those angles.
Well, thank you very much.
Yeah, you're welcome. So how'd your lacrosse season end up? Did you guys?
We ended up making it to the quarterfinals, but then we got knocked out by last year's state champions.
Yeah.
So it was a good game. But I made for Colorado, I made first team All-State for middies.
I was going to ask you. I think I looked up and you made all conference last year, right?
Yeah, yeah.
You made all state this year. Congratulations. How many people make that?
For midfield, there is 6 for
6
first team.
Made all state?
Yeah.
Cool.
That was really exciting.
Cool. I'll bet you made the Denver Post Athlete of the Week at least one week.
That would be cool.
Did you?
Cool.
I don't read the Denver Post.
I don't know. I don't think I've done that yet. Maybe next year I might be able to.
I don't know that they do it every year. That's right. You're only a junior even. Wow, you made all state as a junior. That's fantastic, Nick. You must be a heck of a lacrosse player.
Thank you very much. Yeah, I led the state of Colorado in assists this year.
Wow.
So
cool.
That was fun. That was really cool.
I got a couple of super athletes. I've got another student who is the #1 tennis player in the 6th state Intermountain region.
Wow, that's pretty good.
Casey Ross, yeah. He's been #1 for 3 years, ever since he's been a sophomore. And he's finally turning 18 in July, and he'll have to play in the adult ranks. But
that would be cool.
It's cool to be associated with people that have an element of greatness about them. So,
well, thank you. Thank you very much.
It's fun for me too. So, yeah, good luck with your lacrosse career. Can you become a professional lacrosse player? Do they have such a thing?
Yeah, they have the MLL and the NLL. The MLL is Major League Lacrosse, and they play only in the USA. And then the NLL is National League Lacrosse, and they play in Canada and the USA.
Is that something you have aspirations for?
I'm not sure yet. I haven't figured out if I want to go on that pathway or not.
Think about it more after 4 more years.
Yeah, for sure.
All right.
But definitely. And I think we'll still probably maybe schedule 1 or 2 tutoring sessions in the summer just to keep refreshed.
Yeah, that's a great idea, just to avoid slippage, because slippage is a real problem. It definitely happens. I notice it with my students all the time. When I go from June 1st to September 1st, they've forgotten 30% of what they knew. So, yeah, and I have reduced rates in the summer. My online rate in the summer is like $20 an hour instead of $32. So
cool. Thank you.
Yeah.
And did I let you know about the my ACT and SAT?
No. How'd you do?
So I actually got my ACT back, and I had gone up in math 3 points, and I got a 28 overall.
Wow, that's a big rise. 3 points.
I was excited about that, and then in my SAT, I went from a 560 in math to a 590. Or no, not even a 590. I got a 610.
Wow.
Yeah, and overall I got a 1260 on that.
Wow, that's terrific.
So thank you very much. Your help has not been without, good results.
I'm always loving to hear that. There's nothing a tutor would rather hear than you've made a difference. That I've made a difference. So.
Definitely. Thank you very much, Mr. Cohen.
Well, you have a good summer, and if we have some sessions over the summer, I'll talk to you in the summer.
Yeah, for sure.
I'm always willing to bring the material. That's
okay.
If you need to bring the material, I'll bring it. I'll make up a curriculum.
Cool.
Do a half hour every other week or something.
Yeah, that would be really helpful. I think that would really help.
Yeah. Okay. I'll let you go. Have a good one.
Thank you very much, Mr. Cohen. Have a good summer yourself.
Thank you. Bye-bye.
Bye-bye.